resistance. Okay. Now let us calculate output resistance. Okay. Output resistance. Okay. Of both non-inverting and inverting amplifier. Okay. So now if we see non-inverting amplifier, okay, non-inverting amplifier or inverting amplifier, you have a loop. Loop is always at inverting terminal. Feedback is negative feedback. You have RF here, you have R1 here, okay, and then you are supplying the V input here, and your non-inverting terminal is grounded. Okay, this is your inverting amplifier. Inverting amplifier. Similarly, if I now tell you non-inverting amplifier, so non-inverting amplifier is same. You have same negative feedback at inverting terminal. RF R1, or this time this is ground. Okay, and you are giving V input to here. Okay, so I told you there are many ways to draw. So I am drawing conventional way because drawing in one way is easy. Okay, you can remember easily. And you're getting some V output here, you're getting some V output here. Now we want to calculate output resistance. Okay, so when I want to calculate output resistance, okay, then what I need to do, I need to make all the independent source off. Okay, so make all the independent sources off. Okay, make all the independent sources off. Okay, so when I make independent source, suppose here one source is there, I need to make it off. Okay, here this is source, I need to make it off. Now what become? These two equivalent sources are same. These equivalent circuits are same. Okay, that's why I return output resistance of non-inverting and inverting amplifier. In the both the case, output resistance is same. Okay. Now if I want to calculate output resistance, suppose there is a no feedback. Okay. Now if I say the equivalent resistance of op amp, so I know the equivalent resistance of op amp. So this is my, so I am calculating now for inverting, both are same, both the configuration are same. Okay, so this is my, okay, minus. Now let me change it here itself. I should draw again. So when I make this off, both are same, and now I'm calculating for this one. Okay, and you know the equivalent circuit of a op amp is, I want to see equivalent circuit now at output, because I not bother about at input. So here we have a resistance R0. Okay, and we have voltage dependent source here, plus minus a VID, and that is grounded. Okay, and one loop is coming here, RF. Okay, and this is source here. Okay, now in order to calculate a output resistance, I assume I am putting a source here, Vx. Okay, I am putting a source here, Vx, and I am measuring output current Ix. Okay, so your our output, okay, with feedback will be simply Vx upon Ix. Okay, now suppose this feedback is not there. Now this here some voltage is there. That's why here also now some voltage comes. Okay, even though now you're making short this one, but because of you assuming one source here, because of the source here some voltage is there. Now suppose if this feedback is not there, it is an open circuit. Okay, in the open circuit, this V1 V minus will be 0 because no voltage feedback will be there in this at this point. Okay, when the difference is 0, automatically this is 0. In that case, when it is open, okay, so this is a feed with feedback. If this is open, so in the case of open, you simply Vx upon Ix. Vx upon Ix is your only R naught because this becomes 0. Okay, so current is flowing through this source Vx to R0. Okay, so here voltage, so you can write Vx upon Ix is nothing, that is all the voltage will drop here and current is flowing Ix. So your output resistance will be simply R naught. Okay, output resistance in open loop. Okay, output resistance in open loop.
सर फीडबैक सर्किट
नहीं है
रहेगा।
अगर फीडबैक नहीं है, सपोज फीडबैक नहीं है, तब क्या होगा? अगर मैं आउटपुट रेजिस्टेंस निकाल रहा हूँ, आउटपुट रेजिस्टेंस का डेफिनेशन है Vx अपॉन आई, जहां यहाँ पे जो वोल्टेज है यहाँ से कितना करंट फ्लो हो रहा है। ओके, तो इसके लिए सोर्स मैं एक टेस्ट सोर्स अज्यूम कर रहा हूँ, वैसे वोल्टेज होती है, मैं एक टेस्ट सोर्स अज्यूम कर रहा हूँ, कितना वोल्टेज है कितना करंट है, ये आउटपुट रेजिस्टेंस की डेफिनेशन है। सो आउटपुट रेजिस्टेंस क्या हो जाएगा? Vx बाय Ix दैट विल बी इक्वल टू R नॉट ओनली। तो ये 0 हो जाएगा क्योंकि VID कुछ होगा ही नहीं अगर फीडबैक नहीं जा रहा है तो। ओके, now this is open loop gain. Now I'm calculating for closed loop gain. Okay, this is R of means the output resistance with feedback. Okay, now let us calculate me Vx and Ix. So first let me calculate what is Ix. Okay, so Ix, say this current is say I naught, say this current is I1. Okay, so let me first calculate the current I naught. Okay, I naught, so Ix equals to I naught plus I1. Okay, now what is I naught? I naught is simply, this is Vx, this is A by D. So Vx minus A VID upon R naught. This is my I naught. Okay, and VID difference is what? VID difference is what? Your V plus minus V minus. Okay, and V plus in this particular case is 0. So this become minus V minus. Okay, so put the value here. This become Vx plus A B minus upon R naught. This is your I naught value. Okay. Now, what is the value of Vx? What is the value of V minus? Okay. So V minus value you can easily calculate. V minus value here. This is V minus value. So what is the V minus value? So your V minus will be, you can apply voltage division. V minus will be simply, you have Vx, okay, upon R1 plus Rf, okay, into R1. Is this correct? Okay, so this source is voltage getting drop here and that is getting drop here. So here how much voltage getting drop? Okay, current is coming in this I1. Okay, so the total current is I1. So this is Vx upon Rf plus R1. This is total current into R1. That is your V minus. Okay, so now you have V minus value here. You can put this value here. So your I naught will be what? Your I naught will be Vx, okay, plus A Vx, okay, R1 plus Rf, okay, and this you know, R1 upon, you can write this is the beta Vx. Simply you can write beta Vx. Okay, beta is R1 upon R1 plus F. Okay, so here you can write Vx, okay, Vx plus A beta Vx upon, you have R naught. Okay, this is your value of I naught. Now I want I1 also. Okay, so I1 is simple. So I1 just now, I1 is what? I1 is nothing. I1 is your Vx upon R1 plus Rf. Okay, so I know I naught, no, I know I1. I can easily calculate Ix. So my Ix will be now, okay, sum of these all three. Okay, so you can take Vx common here. Vx, if you take Vx common here, I can write this is 1 plus A beta upon R naught, and this is simply 1 upon R1 plus RF. This is my Ix value. Okay. Now, okay. Now Ix by Vx will be 1 upon R naught of feedback, which output feedback is Ix upon Vx. Okay. And that is equals to what? That is equals to 1 upon R naught 1 plus A beta plus 1 upon R1 plus RF. Okay. So we have the formula for now. Our output resistance with feedback. So initial, for ideal case, output resistance should be 0. Okay. Now, so from here, I can write R feedback is nothing. Okay. Parallel combination of 1 plus A beta. Okay. With R1 plus RF. This is my formula for ROF. Okay. And this further can be simplified if I say that this A beta is infinite. Okay. Gain is infinite, and the fraction what you're supplying here is very small. In if you say A beta is large, okay, or A beta is infinite, or we say I say large. Okay. If large, then this resistance will be small. And in parallel combination, we know small resistance always dominate. Okay. So if A beta is large, that is the loop gain. So you can simply say that my ROF is now almost equal to R naught upon 1 plus A beta. Okay. That means this RO is 1 plus A beta. Okay. And now suppose if you say further, so open loop you have R0. Now with feedback, output is decreasing, it's becoming 1 plus A beta. Okay. And still if you say A beta is very large, so this will be almost equals to 0. Okay. The ideal case, if it is infinite. Okay. If A beta is infinite, if A beta is infinite, then this will be simply, you can write equals to 0, because this 0. Okay. So this is your formula for output resistance. Either you remember this formula or this formula. For large, you can remember this formula. Okay. So this is your output resistance, and that is same for both non-inverting and inverting case. Okay. So any question? So just give me 1 minute. The ink is padding. Okay.
सर
So हाँ
सर मेरा थोड़ा कनेक्शन चला गया था
हाँ
और एक बार सर रेजिस्टेंस का क्लोज लूप के लिए खाली और एक बार सर बता देंगे स्टेप्स
क्लोज लूप क्या है? The resistance is just Vx by Ix. Okay. So I need to calculate what is Ix. So Ix is nothing. Ix is equal to I naught plus I1. Okay. So first I will calculate I naught. I naught is what? Vx minus A B day upon R naught is your I naught. Okay. And I1 is simply Vx from here, Vx upon R1 plus RF. Then I have added both the current. Okay. Once I add both the current, I get this formula Ix by Vx. Okay. And from there I have calculated this one. From कहाँ से तुम्हारा कटा था? कहाँ से कटा था तुम्हारा?
सर वो जो पहला वाला जो स्टेप था क्लोज लूप के लिए
भी क्लोज लूप का पहला स्टेप क्या था? क्लोज
हाँ
नहीं मैंने I naught Ix is equals to I naught plus I1. Okay. And then I will calculate I naught. I naught is simply my this Vx minus A VID R naught. Okay. And this VID is equal to V minus. ओके क्योंकि यहाँ पर क्या है v डिफरेंस कितना है v माइनस, तो ये प्लस हो गया, ये v माइनस हो गया. ओके. और v माइनस की वैल्यू मैंने यहाँ पुट कर दी. v माइनस की वैल्यू क्या दी? ये वाली. ओके. रेजिस्टेंस वोल्टेज अक्रॉस RS. सो v माइनस वाज मेरी सिंपली इट वाज Vx into R1 upon R1 plus RF. This value I have put it here. Okay, और बस फिर दोनों करंट को मैंने ऐड कर दिया, दोनों करंट को ऐड करके इस तरह इस फॉर्म में लिख दिया, और फिर ये दोनों पैरेलल कॉम्बिनेशन आ गया. Okay, now if A beta is large, this factor will dominate. Okay, and if you say assume infinite, then this resistance will be 0.
Okay, sir.
करके देखो, नहीं है तो हाँ हाँ.
At the starting, you said one thing, sir. For
Which?
both non-inverting and inverting, we have to do something stabilize.
I didn't get your question. What are you saying?
Sir, at the starting, sir,
हाँ.
non-inverting and inverting, both are same.
Both same है ना, because when I'm calculating output resistance, I have to make all the voltage and input 0. Okay. So
For
when
that,
I
what how do we do, sir?
so that for that I have made this ground na. How we can make on this source off. Okay, source off means we have to short it. So I have shorted this. So both when I short, this become both same, become same. Okay. So once both are same, I'm calculating only one time. Okay.
Okay.
Okay. So let us do some problem today. Okay. So let me do one now. Okay. Now put the heading. Okay. Applications of inverting amplifier. Okay. Application of inverting configuration. Okay. Voltage shunt feedback inverting amplifier. Okay. So number one is your summing amplifier. Because op-amp can add summing amplifier. Okay. So what is summing amplifier? So this is my minus, this is plus op-amp. Okay. And now I want to add some voltages. Okay. Say this is R1. Say this is V1. Okay. So this is V2. And say this is V3. This resistance is R2. This resistance is R1. This is my feedback. Okay. And here you are getting V0. This is your RF. And this is your ground. Okay. Because now I'm doing inverting, so I have to make this ground. Okay. So now I want to solve, I want to calculate what is my V output. Okay. So it is very easy. Okay. You have to find. Okay. So say suppose this is 0, ideal case, this will be automatically 0. This is 0. This is automatically 0. Okay. So let's say this current is I1, this current is I2, and this current is I3, and total current is going here, say IF. Okay. So what I can write by nodal analysis, I can write my I1 IF is nothing equals to, or I can say my I1 plus I2 plus I3 equals to IF. Can I write like this? Nodal analysis. Incoming
Yes,
current
sir.
equal to outgoing current. So these currents are coming. Okay. And this is going outgoing current. Okay. And now what is your I1? I1 is simply your V1 upon R1 plus V2 upon R2 plus V3 upon R3. Isn't it? Okay. And IF is what? IF is simply your 0 minus V0 upon RF. Okay. Now what will be the value of my V0? So my V0 will be simply, okay, minus R1 minus RF upon R1. Okay. V1 minus RF upon R2 V2. Okay. Minus RF upon R3 V3. Okay. So I know inverting amplifier gain is voltage is what? RF upon R1. Okay. RF upon R1 V1. Okay, so that means this now this output is this is for because of V1, this is because of V2, and this is because of this V3. Okay, now if you put R this R1, R2, R3 is same. Okay, you put if you put R1, R2, R3, all are same. Okay, then you can write V0 is equal to simply RF upon R. Okay, V1 plus V2 plus V3. So this it is summing all the gains. Okay, okay. So you can do this way also. You can do with superposition principle also. In superposition principle, we know how we used to do earlier. If I want to calculate the effect of this source, I have to make others 0. Okay, in that way also you can do it. Okay, so if I make this one 0, so only this will give me output RF up R1 upon RF equal to V1. Only this function will come. Okay, and if I this makes 0, this makes 0, only V2 acting, I'll get this term. Okay, if this is active, these are 0, I'll get only this term. Okay, so you can do it by superposition principle. Are you getting what I'm saying?
Sir, how do we take, did we take that zero at negative terminal?
0
That
means
voltage.
superposition principle ना?
सर इसमें
हाँ।
अब जो लिया है
अभी हाँ क्या लिया है अभी?
जो
ये-
इन्वर्टिंग टर्मिनल पे जीरो क्यों लिया है? इन्वर्टिंग टर्मिनल पे
यहाँ पे 0 है ना? If this is 0, this will be 0. Voltage ground concept is an ideal amplifier.
ओके सर
Okay,
ग्राउंड
ground so voltage will be same in both the places. If here is 0, it automatically is 0 for ideal case. Okay, now all we are doing for ideal case. Okay, this is the ideal means for this AOL is infinite. If not infinite, then there will be some voltage, other voltage. They will be not same position, same thing. Okay, so this is a summing amplifier. Now what I'm saying, superposition principle. What is superposition principle? If you want to calculate output with superposition principle, then what you do, you make it ground. This is also ground. Okay, so if you want to calculate due to only V1, so your V output will come what? Minus RF upon R1 V1. Okay, say this is V01. Similarly, you make this ground and this make active V2 and this ground. Now this case VO2 will be your minus RF upon R2 V2. Okay, and third case your V03 will be minus RF upon R3 V3. Okay, and the total will be your V0 equals to V01 V02 plus V03. V01 is due to V1, V02 is due to V2, and V03 is due to V3. Okay, like this you add, so your 2 will come. Same formula, same like way. So you can do choose any way. What if you don't understand this way? Okay, this ground concept, then you can do with formula, using formula. Okay, minus RF upon R2 V2 minus RF upon R3 V3. Okay, so any confusion, please ask. Okay, now let us say, suppose instead of at inverting terminal, okay, I put it this on other way. Okay, if I put it this one now, I have this op amp. Okay, say I am putting now it in non-inverting. Say this is my R1. Okay, this is my RF. Okay, and this is my V0, and here I am putting say values V1 R. For simplification, I'm only taking R. Okay, that it can be anything. R, say V2, V3, okay. I'm putting like this. This is say grounded. So now tell me how to solve this type of problem. How will you approach this problem? Okay. How can I solve this problem? So this is which inverting amplifier or non-inverting amplifier?
Non-inverting.
So non-inverting amplifier, what I need? What is the formula for gain? What is the formula for gain? V naught equals to 1 plus RF
1
upon
plus RF by
R1
RN.
into
V
what?
input.
V input. And V input is here, isn't it? V input is here. We call V plus. V plus. V input of V plus. So what is find out V plus? If you know the V plus, automatically you can apply this formula and you can solve it. Find out V plus. How can you find V plus? Now V plus is what? Voltage at this point due to these sources. Now you apply nodal analysis. Okay. Now here there is no current. This current is 0. Either you apply nodal analysis or you apply superposition principle. Due to this source, what is voltage here? Due to this source, what is voltage here? Due to this source, what is voltage here? Or you do nodal analysis and find the current. Find the this voltage V plus. Okay. So I'm using both the techniques. Okay. Whichever is comfortable to you use. So I'm talking first. I'm using nodal analysis. Nodal analysis or KCL simply. You said what nodal KCL. Okay. This current is I1. This current is I2. This current is I3. Okay. So what is my I1? I1 is simply V1 minus V plus upon R. I2 is what? V2 minus V plus upon R. And my I3 is simply V3 minus V plus upon R. Okay. Now this sum of this current is 0. No current is going here. So whatever current is going, the sum should be 0. That means my I1 plus I2 plus I3 should be equals to I plus current going to terminal, that is equals to 0. Okay. Now put the values here. So you have V1 minus V plus upon R plus V minus V1 V2 upon R plus V3 minus V plus upon R equals to 0. Okay. Now, what is the value of V plus? Calculate. What is the value of V plus? How much is coming V plus?
V1 plus V2 plus V3 by 3.
Okay. So from here, if I calculate my V plus R will be 0. Okay, simply R will be 0. So my V plus will be simply V1 plus V2 plus V3. Okay, 3V3, that is 3. That is my voltage value. So as I know the voltage value, okay. See, in inverting amplifier, you need this value, you this input. At non-inverting amplifier, you need this value, and then you can apply formula. Once you know this voltage, and you can apply this formula. Okay. Now you can apply the formula. So your V naught will be 1 plus RF upon R1 into V1 plus V2 plus V3 3. Okay. This is your formula for V naught. Okay, this is clear. Now please try this same problem with superposition principle. Okay, you want to calculate V plus. So what is superposition principle now? Superposition principle meaning you have this V1. Okay, this is your V2 and this is your, okay, so this is R I want to find out voltage. What is voltage here? Say voltage is V plus. Okay, so I will find voltage for because of this one. I'll make it ground, and I'll make it this ground. Okay, so say the total V plus is equals to what? V plus due to one source, V plus due to second source, and V plus due to third source. Okay, now this is equivalent. What I can write, this V1 R. Okay, now these two resistors are parallel. They are both grounded, they're parallel, so their total will be how much? R by 2. That will be R by 2. Okay, now what voltage I want? I want this voltage V plus 1. Now V plus 1 is simply what? Voltage across R2. So my V plus 1 will be what? Okay, current is what? V1 upon R plus R by 2 into voltage across R by 2. This will come what? V1 3 R by 2 into R by 2. R cancel, 2 cancel. So simply comes V1 by 3. Okay. Similarly, when I make this ground and I make this active, V2, then
V2 by 3.
so contribution for will be V2 by 3. Similarly, contribution V plus
V3
by
by
3,
3.
V3 by 3. Okay, and total will be like V1 plus V2 by V3 by 3. Okay, so you can use any method. I prefer that earlier method, that is easy. With one step you can do it. So this way, so op-amp generally we use these two techniques, nodal analysis and superposition principle. Okay, to solve almost all the problems. Clear? Okay. So let me do. In doubt? Okay. So let me do now other problems. Okay. So you have been given one source, say 6 volt. You have been given this 20 R minus plus V naught, and this is 20 kilo ohm, say, okay, 20 kilo ohm, and this is your 40 kilo ohm. And here I am putting a 2 voltage source. Okay, please calculate V naught. What is the value of V naught? Again, you can use superposition principle or direct method, whatever you want. So what is the, if this is ideal case? Okay, so what is the voltage at this point? यहाँ पे voltage कितनी है? What is the voltage here?
2 volts.
Very good, 2 volts. So what will be the voltage here?
2 volt.
2 volt. Very good. So same voltage will be here. Okay, because ideal. So ideal means
Minus 6 volt.
minus 6 volt. Very good. Okay, so you can simply now you can do it. Okay, no current is going here, no current going here, no current going here. This 0, all currents are 0. Okay, so you can simply write 6 minus 2 upon 20 kilo ohm is equals to 2 minus V naught upon 40 kilo ohm. Kilo ohm can cancel. This is 1, this is 2. Okay, this 4, 8. So 2 minus V naught. So V naught will be what? Okay, 8 minus 2 minus 6 volt. That's the answer. V naught. Okay, very easy. Op-amp is very easy. Okay, don't we get afraid with this symbol. Symbol nothing to do. Okay, you just have to see what is happening in terminals. Okay, and there are only 3 terminals mainly. Sometimes they will be biasing only. Okay, and if you want, you can do same problem with superposition principle. Okay, so if I apply superposition principle, then what I do, I want to calculate because of this source, so I have to make this ground. Okay, so if I apply superposition principle, okay, so if I say because this was V01, so V01 will be what? Simply now this become what? This become inverting amplifier. So what become? RF upon R, 40 kilo ohm upon 20 kilo ohm into V input 6 kilo ohm cancel 2, so you get how much? 12 volt. Similarly, now if you want to calculate because of this source,
Sir, minus 12.
minus 12 volt. Okay. Similarly, if you want to calculate this source, okay, then you have to make this source as a ground. You turn off this source, okay, and this becomes your now what? Non-inverting amplifier. Non-inverting amplifier. Now say this is V02, so V02 will be simply 1 plus RF 40 kilo ohm upon 20 kilo ohm into V input is 2. Okay, this 2 how much become? 3. This becomes 6. And superposition principle say V0 is equals to V01 plus V02. That is will be your minus 6 volt. So you can use both the techniques. Okay. Okay, now this problem I think came in JEST. Okay. You have minus plus, okay. You have this as R. You have this V input, okay, which is given 2 millivolt. Okay. Then you have this is ground. Okay. Here they are given one resistance, say R. Okay, and here one more resistance is R. This is connected here, V0, and here one more resistance is R. That is grounded. Okay, it says find V0. Calculate V0. How will you do? How will you approach this problem? Okay, so this is ideal. So this is 0. So automatically this will be 0. Okay. Now this node I know, this node I don't know. Okay, say this is Vx. Okay. Now you can apply nodal, you can do nodal analysis, and you can find Vx by using nodal analysis. Okay, and then you can solve this one. Okay, so for example, if I write this one, okay, this is V input. So if I write here, no current is going. Here, no current is going. Okay, so whatever current is coming here, the same current is going here in this here. Okay, so what I can write now, I can write V input minus 0 upon R. Okay, that is current I is equal to 0 minus Vx. 0 minus Vx upon R. Okay. So R cancel. So you can say my Vx is now minus V input, isn't it? Okay. So my Vx is just equal to minus V input. Okay. Now I can write nodal
So 6
analysis.
volt.
Yes, let me check. Minus 6. Minus 6 is 6. Hai. Okay. Now you have to do nodal analysis here. At this, you want to find out what is here. So say current is going here, here, or you say current is coming here. This current is coming here. This going here. Say this going here. Okay. So outgoing current positive, incoming current negative, whatever you want to say. Okay. So this current will be what? Say this current I. Say this current. So you can say this current is I1, I1. Okay. So this current is I2. This current I3. So I1 you know, I2 is what? I2 is your Vx minus 0 upon R. I3 is what? I3 is Vx minus B naught upon R.
Yes, sir. Minus 6.
Okay. Now you know all the current. Okay. So these are incoming current. These are outgoing current. Outgoing current. Okay. So you can write your I1 is equals to I2 plus I3. Okay. I1 is nothing. I1 is your what? I1 is what? 0 minus Vx. Okay. So Vx 0 minus Vx upon R is equal to Vx upon R plus Vx minus V naught upon R. Okay. So this R will cancel. So you got minus Vx. So you got this minus Vx minus 3Vx. So minus V naught equals to minus 3Vx. Okay. So your V naught equals to 3Vx. And your V naught 3Vx is equal to minus input, minus V input. And B input is your 2 millivolts. So this become minus 6 millivolt. So only nodal analysis, what we learned in your first chapter, that is useful here. Okay. And while solving transistor, we are using KVL. Okay. Now we are mainly using this nodal. Is this problem clear?
सर -6 millivolt है ना?
हाँ, minus 6 millivolt है. Minus 6 millivolt. Okay. कोई question? Okay, so I'll give you similar kind of problem. Okay, now that problem you need to do. I will not tell you how to do. I'll give you 5 minutes time. You need to solve that problem. Okay, so say they say op amp is ideal. Op amp is ideal, and they have given you V naught upon V input value as minus 12. Okay, they say find R. Okay, what is this value of R? Find R. Okay, calculate. Same method, same nodal analysis we have done. Tell me the R value.
सर
हम्म
आपका कैमरा ऑफ हो गया। सर इसका आंसर क्या है?
1 किलो ओम। कैसे निकालोगे? Just apply nodal analysis. Okay, so say current is coming here, say this is outgoing, this is outgoing. Okay, so this is incoming, this is outgoing. Okay, say this is I1, say this is I2, say this is I3. So I1 is what? I1 is nothing, 0 minus Bx upon 10 kilo ohm. I2 is what? I2 is your Vx minus V0 upon 10 kilo ohm. And I3 is your Vx upon minus 0 upon R. Okay, now incoming current, outgoing current equal. Okay, so this I1 will be equals to I2 plus I3. Okay, this is minus Vx upon 10 kilo ohm will be equals to I2. I2 is Vx minus V0 upon 10 kilo ohm, and this is Vx minus 0 upon R. Okay, now you want this Vx value, bring all the Vx one side. Okay, so what I can write now,
1 आ रहा है
1. This is minus Vx upon 10 kilo ohm. Okay, this is Vx by 10 kilo ohm, this will also go here, minus Vx upon 10 kilo ohm. Okay, and this is minus Vx upon R, minus Vx upon R equals to minus V0 upon 10 kilo ohm. Okay, now Vx is equals to what? V input minus V input. Okay, so this will become 3V input. Okay, upon, sorry, 2V input, 20V input upon 2V input upon 10 kilo ohm. Okay, similarly this become V input upon R equals to minus V0 upon 10 kilo ohm. Okay, so now I can take this become 5 kilo ohm, and V input I can send there. Okay, so this will give me 1 upon 5 kilo ohm plus 1 upon R equals to minus V0 upon 10 kilo ohm upon V input. Okay, and V0 upon V input value minus 12 is given, already given, minus 12. This value is already given, minus 12. Okay, so this become 12 upon 10 kilo ohm. Okay, that is 1.2 kilo ohm. Okay, so 1 by R is equals to 1.2 kilo ohm minus 1 by 5, that is 0.2 kilo ohm, isn't it? And this become your, sorry, now you have 1 by R. 1 by R is equals to 1.2 minus 1 by 5. Okay, 1 by 5, that is your 5 into, how much comes? 6. 6 minus 1 upon 5. Okay, 5 upon 5, that is 1. So your R will be equals to 1 kilo. Okay, this is also kilo ohm and this is also kilo ohm. Am I right? Am I doing a mistake? (1.2 into 10 to the power minus 3. I should do 1.2 into 10 to the power minus 3. 1.2 into 10 to the power minus 3 I should do here, and this should be 10 to the power minus 3 upon 5. Okay, Now it is correct. So this is 10 raised to the power minus 3. Okay, this is 10 raised to the power minus 3. And when I went to opposite, it will come 1 kilo. 10 raised to the power 3 ohm, that is 1 kilo. Okay, so I'm stopping here now. 5-minute break is there. Then we'll start digital electronics.
Okay, sir. Thank you, sir.
Thank you.